some enthusiasm or like cool things that could be possible. So like, I mean, I had like one breadboard set up, like hooked up to an Arduino. Yeah, well, so I guess I can I'll show you what I have set up, and then I'll disconnect it and just like pass it around, okay? So like there's just different things on there, like a switch and a potentiometer and an IR sensor. And I guess we have code for it and an IDE, so what's your name? Randy or?
Rusty.
Rusty.
Yeah.
Okay, so I guess, yeah, you were playing with this stuff too at some point.
Yeah.
And so, yeah, I mean, I guess the cool thing about the Arduinos is that you can program the pins and make the pins go off and on when you want programmatically. And so, if you have a switch, then, you know, one of the neat things you can do is you can tie electrical components together, sensors of all different sorts. So you can have wireless sensors, like a Bluetooth or Wi-Fi or a remote control sensor, or you can have switches, whatever you want, any kind of input, and then based on that you can control things like servos or motors, and you can build robots. And the nice thing is that a lot of this stuff is already available online. So like, I mean, I guess I had like a few videos, like, so, you know, some people like make, not really sure how well we can, I don't want to play for too long, but, you know, one really cool project that I remember hearing about maybe 3 years ago was creating an automated aquaponics, right? So basically they were able to make their garden internet connect. So like if the plant needed to have things changed, it sent the person tweets. Okay, so how's that possible? Well, you can have sensors in the water, and whenever the sensors detect something that changes, if you have something connected to a microcontroller like an Arduino, and you have a Wi-Fi shield on that, then it could send you, it could ping some server, and then you get a tweet from that. So that's really cool, right? So now we're kind of moving into, so it used to be, you know, the internet was something that people sat down at a mainframe or a computer or a laptop at, and then it moved to mobile with their phones, but now it's getting to the point to where devices that you can play with yourself and make yourself is all connected. So now we're kind of getting into the realm where things are a lot easier. And so one of the things that we'll be able to teach, you know, in future classes, if you like, is that whole concept of how to make those kind of components. I think another one, another little fun project, just real fast. So this person has an Arduino, and they had a little sonar sensor on it, and you know, you could program a robot. Okay, so, and what's really neat about this is like you can see all kinds of YouTube videos where people make their projects for Arduinos or other things like that. And then in the descriptions, more often than not, what you're going to find is that there's going to be some link to code. And so the code that you're going to have is a schematic for how to actually put things up. And then if you're not a programmer, or even if you are, then you can drop into something like this. It looks maybe like hieroglyphics if you've never seen anything like that before. And then you can just tweak it and play with it and just change the behavior. So there's a lot of potential to do cool stuff. That's basically what I'm trying to get at here. Like, do you want to talk about some of the projects that you're interested in as far as this kinds of stuff goes, like electronics or whatever? Sure, yeah, just something real fast, just to show like what's potentially interesting that we could talk about. So depending on what you want.
So for my master's research, I spent, I guess now about a year, building Raspberry Pi, which is a simple. It's essentially like an Arduino, except it's a little bit stronger. It's got an actual processor on there and some RAM. I took a low-level operating system and I put it on that Raspberry Pi, and then I put a virtual intelligence on that Raspberry Pi. I made the Raspberry Pi smart enough to be able to teach itself. Okay? There was a lot of things I had to do and overcome for that. So basically, I took this small little robot, I built a robot around it. It's a robotic arm that if you swing something at it, it'll block it, and then if you swing it the second time, it'll block it faster. It gets faster and faster as it goes. What it's doing is it's learning vectors that you're swinging from, to its code, what it needs to take X amount of time to write. So electrodes are, you would go look here. And so basically I took a Raspberry Pi, I built a robotic arm that you swing at at lunchtime, so it comes around and floppy a second. And so there's projects like that, and then there's other projects that I've worked on, a lot of facial recognition stuff. One thing that I worked on from the beginning was actually if you take a picture of somebody, they would put a mustache on their face, and so you like take a picture of somebody and make them have a mustache, and that used to be really cool. That's kind of where I started, and then I was like, I want to get into these robotic areas, and so I started taking RC cars and taking them apart, making them more on their own, kind of sensors on there, different scopes, so it could be able to do different things. But yeah, so kind of like an Arduino here is a cheaper and smaller version of a Raspberry Pi, but that doesn't mean that it's any less powerful. It's got a microcontroller on that that's very strong, that will be able to understand programming. The benefits of Arduino versus a Raspberry Pi is that it natively understands images. You don't have to put a operating system on there. You don't have to work through everything like that. But you can start somewhere that's at a more beginner level with an Arduino. And so that's hopefully what we're going to be teaching here, is starting with a beginner level of circuits and programming and robotics, so that you can at some point in time build something like I had to do for my thesis. I think I said probably got some projects he wants to talk about.
Yeah, I'm currently working on a project that is basically it's a security system. I basically got into Arduino over the summer. I got into Arduino over the summer and programming and stuff like that, so I'm relatively new. But I've already been able to get a security system working to where whenever you break a door sensor or a magnetic sensor, it'll send you a text message or an email. And before, that kind of technology was only available on like the more expensive side of the security home systems and stuff like that. So basically what I'm getting at is that any problems or anything that are currently going on in your life that you can solve with technology, the Arduino gives you the capability to create different systems in order to solve those problems. So like in the case that he was talking about with his AI robot, different things, that they had a lot of real life possibilities as far as usefulness of it. So it's not like you're just tinkering around with different projects just for the fun of it. You can actually create viable solutions to different issues by playing with it.
Okay. So yeah, I mean, I guess our first idea is to give you like an idea of the kinds of stuff that we can talk about, or like to generate some interest, and then to give you, like, depending on your skill levels, you may not learn anything from a circuits discussion, but if you're still kind of a beginner, we were going to just go over some very base level stuff. If you were going to work with electronics and microcontrollers, like what are like the absolute bare minimum things that you need to know. So you want to talk about circuits, like yeah. So like I guess we have some links over here. I don't know if this is necessarily the best place to start with that discussion, but if you don't know anything, in my mind, like it's kind of intuitive to talk about that model.
Yeah. So with every circuit, there's what's called a circuit diagram. It's just a basic mapping of what you plan on building. So you have a battery, that's the start, and then you'll draw some wires, and it'll go into resistance, and then it'll go into the object that you're trying to do. One of the most basic kind of diagrams you can build is an LED circuit, and that's all it is a battery to a resistor sometimes, depending on your LED, and then to an LED, and then back into the battery, back into the ground. And it's a simple diagram, and it actually looks similar to the one up there. I don't believe that's a LED, that's a DC circuit wire. I don't know exactly. But so there's that, and so you have to build a schematic. You have to draw a design to start, and there's a lot of mathematical equations to figure out those resistances, those calculations that you'll need to know, so that you use the right components. It's actually possible to make things pop and explode, because electricity is dangerous. So you don't have an idea of what you're trying to design, then if you just start hooking components, you're going to break components. And so the schematic is usually where you start, and it's a simple drawing of the square, essentially. That's the ground, or the battery in this situation. And then the far right over there, that's the resistance. And so for a simple diagram, you might want a line from the battery into the resistance, into an LED, and then into the battery again, and that would be that. And then the Arduino comes into play, and that's where you take a little bit more advanced steps, and the Arduino's on the battery. And so whenever you're building it, you represent, you know, the battery the same, your resistance the same, your LED's the same, but where you see the battery, you're actually going to be thinking, this is the Arduino. And so your Arduino is going to have some kind of program that lets you control a light switch. It's going to have an on and off kind of functionality. And so you'll run power through your Arduino all the way to the LED and then back into the Arduino for the input to response if it's on. The resistances are needed to slow down the amount of power, basically, to limit the power going into the LED so the LED doesn't pop or whatever you're building doesn't go down and break. I don't know that we're discussing the diagrams too much as to like what the I means and what different things like that. We're not talking about capacitors so much. We're just trying to get an idea of what the schematic looks like in this first course of our class here. And I think Alex is building something, but
Well, I'm trying to find an LED that's actually working.
okay.
So like a lot of the LEDs, for whatever reason, are not happy. So
One of the things that he's touching on as far as it being like a switch that you can turn like lights on and off on, the way that you can think about it is a really advanced switch that can do a multitude of different things. It can take inputs and then use a program to transfer those outputs also. So it's just like one of the most basic things that you can do is like an LED is make it blink an SOS symbol, which you can do manually, but it would take a lot more work basically. It's like you switching it on, you switching it off. So it's basically, imagine a light switch, right? You have your power running to the light switch, and the switch gives it it either passes on the current or does it based on your position of it. And with an Arduino, what can run as a battery also, you still need to have a power source for it, so it's not, like it is a power source, but basically you run the power source through it, and then depending on what your programming is what the output will be. So imagine if you had okay, so he has a remote on it basically, right? So he has a IR sensor, which is the same kind of remote that you have in your TV that's infrared that allows you to control that. And based on his programming, it says, based on the input that I get, it'll either turn this on or it'll turn it off. And if you wanted to, you could even make it to where it flickers on and off, and that would also just be based on the programming.
okay. So probably the simplest circuit is an LED switch. So can you explain the simplest?
Okay. So the V, the V of the battery are the plus or minus. That's your battery essentially. That's the positive and the ground for voltage is going to be the next the next is where you're going to go kind of symbolized there, and then your anode is considered where the LED is. It's going to be where the and then you're going to resistance going back.
So future classes, probably we would want a camera to where we can zoom in on what we're doing up here. But I can pass this around. Basically, one of the pins is delivering power and the other pin is acting as a ground. And we're just feeding into here. So who is familiar with, is everyone familiar? Who is not familiar with breadboard? You guys familiar with breadboards? Probably not. No? Okay. So yeah, let's break down breadboards, because basically when you're making a circuit, it has to be complete, right? It has to be a loop that's closed. It that's the fun, like, so the water analogy that we had up, if you think of water going through a pipe, then the pressure is the voltage, right? And so the Arduinos, they deliver 5 volts, and so that's basically the pressure of the electrons that's flowing through. And to have a light, or if you have an electrical component, it expects to have a certain voltage and then a certain current. And the current is just how much electricity is passing through. The difference between the water analogy and the circuit is if you were to cut a pipe, water would just come out everywhere, right? Well, with the circuit, since air is an insulator, it can't get through, your circuit's just going to be off. So just pass this around real fast. This would be the simplest kind of circuit that we would be able to make. Oh, hey. And generally, if you're making circuits from a diagram, it might look crazy like this. So like this website, instructables.com, it's a really great website. Like all the links that we have, like if you give us your email afterwards, like we can go ahead and just email you all these links. But if you don't know, like circuit diagrams might just look like a random piece of some monster, right? And so there's different places like this that'll actually explain what are all the different symbols. Okay, and so if you're people don't just study hieroglyphics, right? These are basic things where you can look at each individual component that represents an electrical component that would actually be in the circuit. Let's see. Oh, and with the LEDs, some of these LEDs, like the blue one, it can take more current than others. So there's different color circuits. If we were to do the exact same thing that I did before, so here are different components. If I were to do the exact same thing as before with a red LED or a yellow LED, it would pop. And the reason for that is that the blue can take more electron flow than some of the other colors. And so so there's a component that allows you to handle that. Like if you want to have less so that you're not blowing up your electrical components, you can use what's called a resistor, which is what Morgan explained earlier. And so resistors are like sand. So if you think of water flowing through a pipe, if you were to have a sand filter in there slowing down the flow, that's how a resistor, or that would be the analogy of how a resistor works. And so if you want to explain, okay, so we have some resistors.
So I just handed it.
Oh, you just handed out some.
I handed them this here.
Okay, sure.
But, yeah, the resistor is just color coded. So you see there's bands on the resistor and they represent different, what the material is that the resistor is made out of. Different materials have different resistances. Like gold, for example, would be
They all
very low
random
resistance,
colors on
very
them.
high
Alex.
gold, essentially. And so these different colors here on the bands on the resistor.
Yeah, they do.
So
they try to most of them, they have different color bands, and so there's equations that will tell you how to read it. I mean, I guess we can go over all that, but actually what a lot of people will do is they'll organize the resistors, because when you buy the resistors, they normally come like this, but a lot of people will organize them in sleeves.
Oh yeah.
So yeah, just
like baseball cards.
Yeah, like baseball cards. So you just figure out the values and then you put them in your sleeve so that you don't have to scramble through them all the time. So that's probably something that we'll do next. But,
yeah.
I just wish they had more consistent colors.
Oh yeah.
The bands, if the colors were better consistent.
Yeah, that's true.
Because recognition, so you don't have to.
Color recognition,
Yeah,
yeah,
if
way
the-
faster.
If the printed resistors, the colors they don't use a good uniform spectrum. If they did, it's not that hard to. You could just do a lookup, and so you don't ever have
Right.
to read the damn thing.
Maybe we need to invent one at ULabs.
It's something I've thought about for years. It's
Yeah.
just,
Alex,
brand 1 versus brand 2.
he has an excellent point. Please repeat.
I just wish the people who made resistors used a more consistent palette for the bands, because I'm lazy.
yeah, exactly.
Color recognition is a pretty trivial feat in image processing.
Right.
So if the colors were consistent, you never have to do a lookup. Unfortunately,
Yes.
the colors on resistors
We should
aren't.
create a standardized system for those.
Well, I mean, the manufacturers maybe. 'Cause
Yeah.
that would be a fun.
An
I always
app.
end up just like sticking the multimeter on it and saying,
Yeah,
oh, that's a this
That's what I do. I don't
because they're
bother-
only 10% tolerant anyway, and so sometimes that's okay if it's plus or minus 10%. And
Well,
then,
you-
then
you know
sometimes
the
you want a
value
more
is
accurate
it doesn't
one.
go until you have to.
It's true.
Well, no. But, yes, but then I have to look up the chart.
So you have to
I agree.
I really wish.
Laziness drives all the best
Yeah.
innovations.
Oh, I'm firmly of the opinion that most programmers have both. It's both their greatest values and their greatest detriment. It's equal parts of hubris and laziness. You could do all sorts of things because, well, of course I could do that, and it would be hard to do it otherwise. So I can be lazy and prideful, or
Very true.
they get caught up in World of Warcraft and 6 months go by and the cat has wandered away.
And they do all the work in one night.
Yeah, it's both. It's quite figuratively the double-edged sword of.
It's called Crazy Genius. What is it? Sorry? Do we need a night? Yes.
Yeah, can be done.
So the flow is actually not going to be very straight.
So how you been?
Not bad. Were you? I hadn't seen you in a while,
Yeah, I
man.
know. I've been coming by here a lot. I haven't been.
I haven't really. I came for that big party thing.
Oh, that other Friday.
But
Yeah.
that Friday. Hey, Mark.
Oh,
Just learned about resistors.
fun. Okay. I think I've met you before.
Probably, yeah.
Okay.
Yeah, Mark.
That like first time.
He and I work together. Yeah.
So,
Oh, yeah,
I'm a
in
camera.
our
Yeah.
conversation.
I'm a camera.
Yeah, they were just explaining basics of electronics and stuff.
Yeah. I just like randomly kind of like walked in here to see what was going on.
Do what?
I didn't even realize there was a class going on.
They put an invite on Facebook, and it had like details and stuff. It wasn't just like vagaries, and so
Oh, really?
I think maybe some more people responded.
Oh,
because of
yeah.
that.
I'm not into Facebook. I haven't looked at their Facebook thing yet. This place has changed a lot, man, since the last time meeting.
Yeah. Well, I think they had the original black box because of the water. They had fans playing in there, and like the toilets like overflowing, and everything was covered in water. So I think that's why I worked out all the apartment. It was crazy. There was like 100 or more people here, like on that night. It was just wild. Like I think they probably had 200 or 300 people.
This was on that Friday night.
Yeah. Like this place was packed. Like
And there was
everything.
like toilet was overfull.
Yeah, there was like 3 bands playing in there, and they had some kind of display thing in one of the side rooms, like with a projector. Or I better not say anything bad.
Yeah, I've got you recorded. It's going
Like,
on
did you
Facebook.
know that on the 5th of December, that guy said?
Yeah, we'll have to edit that out.
Yeah, I got here a little late. I didn't hear early on. I think Morgan was talking about his robot arm, wasn't he? A little bit.
Yeah, his Raspberry Pi. Yeah.
Yeah, it was only like what, a month and a half ago that this was just
Oh yeah.
full of crap.
And even then it was like that for a long time, and then within like a week before that big party, like everything changed.
Yeah, they were here like every day until like 2 in the morning, like
Yeah.
just doing stuff.
Ridiculous stuff.
I just,
They did put some like painting on the walls during their house.
yeah, oh yeah, the whole place was covered in. I think there was 100 pieces of art. Like even over here, there was like
Yeah.
10 things hung up.
Uh-huh.
Yeah, it was like the night before. Sabah was like, "Hey, can you come help us?" And I was like, "Sure." So I came after work, and I pretty much just swept the floors and crap like that. And then they were like, "Yeah, okay, the party started." I'm like, "Oh, Oh, there's a party. Okay. Didn't have to bring that home.
All this fun stuff here.
Did you go back home for the break?
Yeah, I went to Austin. It's
Excellent.
a 6-7 hour drive. But I haven't seen my family in like a year or so. So it's
Oh,
good
man.
seeing them again.
Are you gonna go back over Christmas too?
Yeah. For a few days.
Are you finished with? Is it finals yet? Is it next
It's
week?
like next week.
How's that going?
It's good. But I'm kind of like losing my enthusiasm for it. I've been getting into, like, I took over a website for these this spawn time. I've been doing all these things to make it faster.
Oh, cool.
And I've got a lot of loading like really fast. It's
For which site?
RenaissanceRoofingSpawn.com.
Okay, cool.
And like it's just like so addicting, like learning about how to make it faster. And I've been making like
You've been bitten by the software bug, haven't you?
yeah. And I've been doing all these things to make it like search engine friendly and all. And it's like so like addictive. Just look up all the data.
I can see that because it is like software's a little bit more accessible, like with mechanical stuff. There's a lot of like barriers to get into it sometimes.
Yeah.
And there's not as much like, I'm playing with it.
Yeah.
Fun. Well, man, it's never too late to change your focus if you want to do
Yeah.
software.
Yeah. But I've been learning myself like JavaScript and PHP and all that.
Excellent.
I wrote some. I integrated some programs with them
Yeah.
online. Just to
That's how
like
you
throw JavaScripts and to like load other JavaScripts like later on.
Excellent.
Make it all and minimize your HTTP requests and all that.
Excellent. Been sticking in the developer tools section
I've
of
been getting into
Chrome.
all that and learning all about WordPress.
Man, one of the worst examples, if you ever want to look at a site and laugh, is everything for the city of Lubbock.
Oh yeah.
Their page loads are like 3 megabytes.
I know.
And it's because their content management system tries to take all the JavaScripts that anything on the site would ever use and squish them into one big request. And so they have like 50 JavaScript libraries that load, and you're just like, what the? Like
Yeah.
you're trying to load one page just to like get a date or a phone number or something, and it's like,
their website's terrible. I was trying to find information about that Civic Center thing. I posted on Reddit a few weeks ago,
oh yeah,
and there wasn't any information on Lubbock
Yeah.
about that.
I actually found the.
Yeah, you found that the one.
I only knew that because a friend of mine's wife was involved with Junior League, and so she'd been complaining about how much they had to do to prepare for that and all that. So
Yeah.
I just happened to know what it was.
I heard
yeah, and
like a lot of cities' websites are managed by like people in other states or something.
I bet they are.
Huge lack of communication. Yeah.
I think for a while they had like the lead web developer at City of Lubbock job posted. Yeah, like they had it up on their site, I mean, it's a vague job posting a little bit, but it's pretty clear that it was like you're in charge of
Everything.
the web.
There's so much
I'm gonna get some drink more.
I'm gonna turn this off. I guess.